So we are currently in the laboratory, and like as I promised in the previous video, we are going to be carrying out the experiment in real time. So right now we're about to see how this experiment can be carried out. If this comes out during the exam, so you do not have any need to be scared. All right. So we have our assembly currently. Everything is set up. We have our spiral spring, and we have the thread which was demanded. They demanded the thread, and this is the meter row. Okay, so I chose an arbitrary point since I did not have a question basically. So I chose point 20 centimeters and also 70 centimeters, providing 50 centimeters in between the threads. So if I have 50 centimeters in between, it means that the midpoint will be at 45. From 20 to 70 is 50, so the midpoint will be at the 45 centimeter mark. Alright, so we're about to carry out the experiment. As you know, this experiment is basically trying to get the period of oscillation when a mass is attached to this spring, like you know, mass attached to a spring. Okay, so now we're going to carry out experiments one after the other from 150 grams to 200 grams to 250 and 300, so on and so forth as required. All right, so I have my fellow scientists here. They'll be helping me out. All right, so let us flow. All right. Okay, so let's go. We have our stopwatch ready. So we are working with 20 oscillations. So I'm going to displace this downwards, and we're going to take the time taken for 20 oscillations. Remember, whatever we are doing here is not to say that this is what WAEC will bring out to the moon. We are just trying to predict and prepare ourselves. Malpractice is not allowed here. Malpractice is not encouraged here. Okay, so the question can be 10, can be 15, can even be something different from this. We are just preparing, predicting and predicting. Okay, so let's start. So are we ready?
Yes.
Alright, so let's go. I'm going to displace downward and we're going to give 20 oscillations and get the time. So we start. Are we ready? Are we ready? Alright, 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 12.25, what do you get? 12. Okay, let's work with 12.25 first. Alright, so please take that down. So we're going to carry out the experiment again for a second attempt because we are trying to get the best possible value by cutting out error. So let's go again, still on 150 grams. Are we ready? Okay, so 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What is that? 7.65. Okay, second one is sugar to our face, so we use that one. 12.65. Record that, please. Alright, so we are pretty much done with that for 150 grams. At the end of the day, I'm going to post the table of values. Okay, it is being recorded currently. So we have obtained T1 and T2. So we are going to sum T1 and T2 and divide by 2 to get our actual value. So we'll move on to the next mass. So here is 150. So adding an extra 50 grams will make it 200. Okay, so we go. Alright. Let's see what this one reads this time around. Okay. For 200 grams now. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 13.29. 13.29. Let's say 13.29. This is down. So that's 13.29. So we take this experiment again to get the second value, which we are going to sum to the first and divide by 2. Right, so let's go. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 13.28. So we'll go with 13.28. Alright, so please record that down. 13.28. So we are done with 200 grams. Like I said, we'll sum these two values, divide by 2 to get our actual value. Alright? I'm still going to post the table of values after this. So we'll move on to the next. I'm going to add an extra 50 to make this 250. Okay, so this is 250 right away. So let's go. For 250 grams, from the first one, 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
14.35.
14.35. 14.35. 14.54.
Let's start again.
Let's take 14.35, right? 14.35. So that's our first reading, T1. So we'll do the same for 250. We'll do it again for 250. We are using 14.35. All right. So let's roll our second reading. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 14.78. Alright, so this is for what? 250. So we'll move on to 300. So we are about to do for 300. We just concluded 250. So let's do for 300. Same. We get a T1 and T2. Then get the actual value by dividing the sum of T1 and T2 by 2. That's a nice line. T1 and T2. Alright, let's continue. So we go at the count of 3. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
14.56. 15.03.
Go down 15.03. Because it's supposed to be advancing. So let's go.
Suppose. Okay, like the weight that the force that you use to push the string doesn't say
Doesn't affect it. Alright, so I can even press it down.
It makes it slower.
No, it won't affect it. Right? 3, 2, 1. 3, 2, 1. Are we ready? 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
14.6. 15.25.
Check this one. So the T2 is 15.21. 15.21. Alright? So we are done with 200 grams. We are done with 300 grams. So we'll proceed to the last one by adding an extra 50 to make it 350 grams. We'll do the same thing. Just basically repeat the experiment. Get our T1 value, get our T2 value, then obtain the actual. Then we can proceed with the other thing on our table of values. Yes, please. Alright, so let's go. Are we ready? 3, 2, this is for 300 grams, alright? Sorry, 350 grams. Okay, so 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 15.63. So T1 value is 15.63 for 350 grams. So we repeat that again. So I will end up getting the average value at the end of the day. So are we ready? 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 15.28. So T2, we're going to go with this value 15.28. So basically, we just ran through the masses 150 to 350 grams while obtaining the time for 20 oscillations. Alright, so the next phase will be for us to work on our table of values and get to know the possible questions that will be asked. Also, I will likely give a very possible graph, where the graph is going to look like, and the questions that may follow. Alright, so thank you. This is our practical aspect. So stay tuned for the table of values and interpretation. Alright, so we have come to the end of the practical experiment for experiment 1. Like I mentioned, it is one of 4 experiments. This is just for experiment 1, and we just executed this system. So you'll be seeing the table of values very soon, but until then, so that you don't get to miss out on anything from this channel, Physics with Paulamin, I will need you to subscribe if you have not done so, and I will need you to push that notification button so that you don't get to miss out on any of our subsequent videos. Alright, so from me and my fellow scientists in the Ministry of Physics, we say thank you for watching. Alright, like promised, we have the table of values that we obtained from our just concluded experiment for values of 150 grams, 200 grams, 250, and 300 to 350 grams. Okay, so these are T1 value, T2 values. Okay, the reason we did this was to reduce the amount of error that we must have encountered during the experiment. So we have to do it twice, and we are going to take the actual value. The actual value is obtained by summing the T1 and the T2 values and dividing by 2 to obtain the actual value. Alright, so we'll start with the first one. We have 12.25 and 12.65. We'll sum and divide by 2 to obtain the actual value. And what did that give to us?
12.45.
So we have 12.45. Okay, so this is the actual value for 150 grams. Now, for the second one, 12.29 plus 12.28 divided by 2. That will give us what?
12.285.
12.285. Okay, so then let's put that to 2 decimals so that we'll minimize everything. 12.285 should be 12.30, right?
Yeah.
So we have 12.30. So let's do the second one. 14.35 plus 14.78 divided by 2. That will give us
14.565.
14.565. That should be 57, right?
Yeah.
14.57. So we'll go for the second one. Sorry, for 300 grams now. To be 15.03 plus 15.21 divided by 2. That should give us.
That will give us 15.12.
15.12. 15.12, right?
Yes.
Okay, so the last one for 350 grams, 15.63 plus 15.28 and divide by 2 to get.
That will give us 15.455.
15.455. So that will go for 46, alright? So 15.46. So these are actual values for the experiments we carried out. Alright, so now I want to obtain the period for each of these masses, 150 down to 350. And we consider 20 oscillations for this experiment. Like I said, it all depends on what is asked. All of these are just predictions and just to prepare us. Alright, so for every of our actual time, we are going to divide by 20 oscillations. So we'll start with 12.45. So 12.45 will be divided by 20. That will give us, so 2 decimal places 2.
Okay, 2 decimal places, 0.62.
0.62. All of this is because we are considering our graph. Alright? We are considering our graph and trying to make it easy for us to plot. So 0.62. Let's go for. Oh, no, let's take the 2 decimals. 3 decimals, please.
That was 0.623.
623, right?
Yeah.
Let's do this one. Alright? 623. Okay. Next one, 12.30 divided by 20.
That would be 0.615.
0.615. Okay. Next one.
Next one is going to be 0.7285.
0.729.
0.729.
Alright. Then for 300 grams, 15.12 divided by 20.
0.756.
0.756. Oh, 756. And the last one for 350 grams. For 350 grams. For 350 grams. That was what?
0.773.
0.773. Alright, so this is the period for 20 oscillations. So we go in the square. also to 3 decimals, the square of this value, 0.623.
It's going to be 0.3 to 2 decimals.
Yes?
0.39.
0.39.
Yes.
390 you mean?
Yes.
Alright.
399.
399.
Yes.
Okay. Okay, so we'll go for the next one. 200 grams.
0.378.
0.378.
Yes.
Okay. The next one.
That will be 0.531.
0.531.
The next one is going to be
Okay.
0.571.
0.571. Next one. That's last year.
That's going to be 0.597. No, 598.
0.598. Alright, so we have obtained t squared values. Okay, so pretty much this is how your table of values should look like. Okay, so in the previous video I explained the theory behind expected question and what to plot for the practical. Alright? And what to plot for the practical. So I will look over to now, so I will see what we are expected to get. So from the period of the loaded spring, we have that t is equal to 2 pi, the square root of mass over force constant. Alright? So this is the period of the loaded spring. The period of the loaded spring. So if I take the square of both sides, this will be t squared equals 4 pi squared m over what? M over k. So most likely, they will likely ask you to draw a graph of t squared against m. That's the mass that we attached. The masses that we attached, t squared against m. And if this is so, it means that t squared is on vertical y-axis and the mass is on the horizontal x-axis. If we solve this, we'll see that this is 4 pi squared over k. Alright? T squared against n is the slope of the graph. Like change in t squared over change in n. This will represent the slope. And everything that the slope is will be equal to 4 pi squared over k. So from here, we will likely be asked to find the force constant of the spring used in this particular experiment. Alright? So that's basically what we should be expecting for this experiment. Alright? The graph, hopefully, I'll show you how the graph will look like and how you can deduce all other things. Okay, so before I go, I also want to enlighten you on some precautions you need to take. Alright? Like you observe when we're carrying out the experiment, we ensure that the spiral spring is placed perfectly vertical and then the horizontal root was placed perfectly horizontal, and then you need to avoid air resistance. Air has a way of affecting the free oscillation of the body. Okay, so you want to shut out channels for airflow. Okay, so basically those are things you need to consider and precautions you need to take to obtain accurate values. Alright, I want to believe this has been helpful, and trust me, like I told you, I am very sure, I'm very certain that 70%, 80%, it will likely be in this direction. It will likely be in this direction. Thank you once again for following and being a part of Physics with Paulamin. If you have not subscribed, press the subscribe button and the notification button to stay updated on all things physics made easy. Thank you.